In this example, we have that f is represented by the graph shown below, and we want to draw the graph of f performing these operations, the graph of g, I'm sorry, we want to draw the graph of g performing these operations to f, to this graph right there. So to do this, I start by first identifying what the x and y values are to this function. And again, because this is a polygon, I'm going to just simply use the vertices to the polygon because the graph will automatically, the software will automatically connect these points. So starting with the one on the far left, which is, as you see that dot that I just drew, -9, -1, I can then identify this one, which is 6, 2, and then the last one, which is 9, 0. Okay, so now that I have those, I want to now transform those points using again this notation. We begin again with the x coordinates and see if we're doing any type of transformation to the x, and we are. We're multiplying those x's by 3, or at least that's what it says right here. It says here to multiply the x's by 3. But as you recall again from the notes, this is not going to actually do that. This is not going to make this longer, because obviously if I do that, it doesn't make sense. How am I going to plot those points? How am I going to plot 6 times 3? That's going to be 18. There's no way to be able to plot that. I can't go all the way over to 18. The reason for that is because this doesn't actually stretch this horizontally. It actually shrinks it. Because the operation when we're doing anything to the x is the opposite of whatever is indicated here. So instead of thinking about this as x times 3, the proper way of what this is actually doing is x divided by 3. So we're going to perform this operation to these values. So we're going to end up with -9. I'm sorry, -9 divided by 3 is -3. 6 divided by 3 is 2. And then the 9 divided by 3 is +3. So this is going to result in shrinking this horizontally. So instead of making it wider than it already is, we're going to make it skinnier. Now, we also are performing operations outside. So we're doing these two things here. We're resulting in a vertical reflection and a vertical shift, a vertical move, a vertical slide. Because we already did this operation, I'm going to rewrite this over here on the right. And I'm going to think about this as -1, because there's no number there, -1 times f of x minus 1. So you see, I want to perform these two things to my f of x value. So these three numbers, these are my f of x values. So I want to multiply by -1 and subtract 1. Now, because of order operation, multiplication takes priority from subtraction. So I'm going to do this first before that. So multiplying this number by this -1 will be +1, and then that number -1 is 0. Doing the same thing with this value, 2 times -1 is -2, -1 is -3, and then finally 0 times -1 is 0, and 0 minus 1 is -1. Now, because I put these points again, I started right here. When I plot these points, they're going to connect again in that order. So as long as you don't start in the middle, again, you should be good. As long as you start on the left or on the right possibly, but never in the middle. When you plot these points, they'll connect again in the right order. So let's plot these points. So -3, 0 will be right here. That's going to be connected to 2, -3. And that line will automatically appear. And then when you plot the third point, 3, -1, which is just right there, this second line will automatically appear. And there you have the transformation of f, aka your graph of g. Hopefully this video was helpful.